Okay, so I hope my screen is visible. If not, then please enter. So we had reached chapter 5 in this week. Till yesterday, we had almost covered up till DC AC cable sizing. So all of you who are there, I hope you must have got a chance to go through the cable sizing part also. I had already shared chapter 5 in the group, and anyhow, like cable sizing is, I'll not say that's much required for this training program, but considering if you are interested in learning balance of system, uh, detail engineering, then you can use it, and even it might be helpful for people who are into maintenance, and even if you are into projects, then cable sizing is a useful tool, whether you're doing BESS or any other project, right? So I hope you all had got familiarity with that and are confident on that. If you haven't worked on cable sizing earlier, then I'll suggest that keep practicing and gradually you'll be able to understand that, because it's not that much of a tough topic. A main thing to understand yesterday was you should get an idea where you need to do cable sizing and where you probably need not be doing, because as I told yesterday, in case of PV, you are supposed to pretty much, you have to do DC cable sizing at almost all location, because you need to connect your strings to the combiner box to the inverter, and then further inverter to other places. But it might not be the case in best projects, because many times you can have containers with battery as well as inverter. And if it is only battery container, then you might have a compact substation where you already have inverter, transformer, RMU switchgear, everything hooked up, right? So you might have to do only DC cable sizing there and MV cable sizing. And if their inverter is within the battery container, then you might have to do only AC cable sizing. DC may not be required, right? So the concept needs to be clear. If that's clear, then we are pretty much good to go. Just 1 second. I don't know why this file is hanging again and again. Oh, probably some issue with this file. Just 1 second. Okay. So I hope all of you can see the screen and the content is visible. So yeah, everyone okay up till cable sizing, right? No doubts up till this point, right? AC cable as well as DC cables. Yeah. Hello.
Yeah, clear, Nikhil. Yeah, yeah.
Okay, great. Okay, so moving on with the next topic, that is if you prepare an SLD or a configuration, like if I have to just draw it here, then we understood things related to battery first, right? So there was a battery container, right? Probably multiple battery containers which are containing different megawatt hour, kilowatt hour storage of battery, which are probably connected to certain inverter, right? To the DC side of inverter, right? From inverter, then it will get connected to probably some kind of a transformer, yeah, Probably say for example a three winding transformer. Okay, so likewise there are two containers or maybe one container, anything. The combination could be anything that we'll have to see on the storage capacity basis. But yeah, so we have understood everything related to battery, we understood everything related to inverter, we understood things related to the cable sizing also. So where we move on now next, we move on to the IDT, this portion, right? Because you know your energy storage container, you know your PCS, you know how to connect the PCS with inverter, you know how to connect the PCS with transformer. So the next step in this whole process or in this balance of system is, first is our transformer, then transformer will step up to some MV level, which could be either 11 kV or 33 kV in most of the countries, which will again get clubbed at some switchgear level, right? So that might get connected at some MV switchgear, from where you will be pulling different power from probably different transformers, right? And then from there either you will be connected directly to the grid if it is at 11 or 33, but if it is at a higher potential, then you might have again put up a power transformer of 132 by 33 or whatever 220 by 33, right? And then you connect it to the grid, right? So what are we actually, why this chapter 5 is all about? The chapter 5 is all about a balance of system. So we understood the cables, we mainly understood the cables as of now. We little bit understood the balance of system in our best container, which was the container itself, the cooling system, the fire suppression system. So now what we are going to understand is the transformers. So we'll try to cover up both topics, that is inverter transformer as well as the power transformer. So in case you feel there is any doubt or any confusion, then please ask related to that, right? So I'll just cancel this out and we'll try to focus and understand how the selection of this. Is anyone aware like how the transformer is selected in solar or battery? Any of you would like to comment based on whatever you have understood till now? Anyone?
It should be according to the investors. Uh, the only thing maybe I would like to know today is maybe I open it before is how much we should oversize the transformer. Maybe we can come to that later, but usually
Yeah, correct. So what our friend said is very correct. So mainly, you might have many times heard something called as transformer sizing. People still use this concept in case of even renewable plant. But as our friend said, I don't believe there is any transformer sizing in renewable. Forget about solar or even wind or even battery, because there's nothing much to size. There's some basics which we'll try to understand here, but there's no big sizing because it's very simple. Whatever is your inverter rating, that more or less tells you what transformer you have to go. So you know your minimum rating. The only thing you have to decide is you want to go with that minimum or you want to consider a little bit of design margin, as our friend said, right? The challenge of transformer sizing is predominantly when we are doing any kind of industrial plants. So in plant, based on again that same Excel sheet which we studied in chapter 1, you need to decide the overall kW or kVA of that particular distribution transformer or power transformer, and you decide, and you need to also consider future addition which could happen, design margins, lot of other thing. And thus there is some kind of transformer sizing which needs to be done in industry, because there are a number of motor loads, other things, and at the same time different motor startings at different point of time, so motor starting also needs to be taken into consideration. But there is no such criticality in renewable, that's very clear. So you should feel very confident that it's very simple, right? So let's first understand the most simple thing, and then we'll try to dig deeper, right? So let me better show it with an essay. Dhananjay, I think because of your two login, it is creating this issue. Yeah. Okay. So moving on. So what happens here is okay. Let me first try to show this. This is 1250. Okay. Okay. So this one is a pretty old project, almost I guess now close to maybe 8 years. This project was done almost 8 years back. So now what you see here is it's pretty simple. So if you see in this project, we had gone with an inverter block of 5 megawatt. That inverter station block of 5 megawatt consisted of generally four central inverters. As you can see, one, two, three, four. All four inverters, that same Seaning inverter which I had shown to you, 1250 kilowatt. Because the nominal if you all recollect, that inverter was also having a rating of 1360 or something like that. Do you remember that? Anyone? Let me just open the data sheet also for you. This is that same project data sheet. So can you see 1320
Yes.
at 50 degrees centigrade 1406, but nominal even here nominal is also higher, but we had presented it as 1250. As I said, we can always restrict the maximum output power also by informing that to our supplier. But anyhow, even if it gives 1 through 1320, there's no problem, because what happens is I'll try to explain that bit later. So right now just consider that the inverter rating is 1250 and there are four inverters. So the logic is pretty simple. We had gone with we were supposed to go with a 5 MVA, but these were projects, I'll say, almost 8 to 10 years back. So that time we still used to consider little bit contingency or margin. But I can show you one more example after that where it was 2.5 megawatt four numbers, but we went with only 10 MVA. Here we had went with 5.3. If possible, then let me try to show you that also, so that you get an idea that there's no such mandatory thing in this, but you can always control certain things as per situation's demand, right? So this is probably 5 or 6 years old project. In this case, if you see, again, in this project we had gone 5 megawatt block, but here we have gone with 10 megawatt block, 2.5 megawatt, double the inverter capacity what I had used earlier, 2.5. And we have increased the transformer. Here can you see the transformer is only 10,000, but here we have considered 5,300. Even though this, both the projects are till date operational perfectly well. So can anyone tell me what's the logic behind this? So first thing, you have understood that the transformer rating is straight away dependent on how many inverters or what rating inverters I'm connected to that. Everyone is clear about this?
Yes, that's clear.
Yeah. So now my simple question is, what is your understanding or your logic? Whether you need to consider design margin or you need not consider design margin. First, let me have your take on that, and then I'll try to give you what I think about that.
See, I will tell my opinion on this.
Yeah, yeah, sure.
Uh, the inverter, it can reach to its maximum at the noon, maybe 1 or 2 hours. This is can give the maximum. This is one side.
Mm-hmm.
Rest of the time, it will not reach to the transformer rating.
Mm-hmm.
But there is one thing to consider: is the inverter. Sorry, the transformer should be capable of handling 100% of the inverter in case happen for 1 hour or 2 hours. I think this is important. I
Mm-hmm.
remember one project it was, even though it's 90, but maybe the design of the transformer was not capable to handle, so it was heat up. So maybe this is key consideration to check in regarding the transformer.
Yeah. Faisal, I think just your voice was interrupting. Somewhere it was interrupting. I don't know, some network issue or maybe mic issue.
No, no, maybe internet, but I'm not sure where it's cut. But
Yeah. Yeah, no problem. Okay, I got your point. What you said, I little bit understood. There was a couple of interruptions, but I understood. So your logic and reasoning is perfectly right. To all our friends who are there in the session, what Faisal said is pretty much bang on. The simple logic is when I am designing the transformer for a plant, we still consider design margin and then future addition lot of things. So the first thing which I know very clearly is there is no future addition here, right? In plant, we need to do design margin because there could be addition of loads in future, there could be expansion of plant, n number of things. But do you think there is going to be any expansion in a PV generation plant or a wind generation plant or a battery storage plant? Even if there is going to be a replacement, it will be a one-on-one replacement, right? You can't add anything here. Agree to this?
yes,
Yeah.
agreed.
Yeah. So first that margin is cancelled off. Second thing is, uh, you generally in plant what happen, you consider design margin. One is for future, and second is because your same transformer is operational every year on year for 20, 30, 40 years. So gradually that transformer is also going to gradually degrade. I'll not say that it will immediately degrade, but gradually, because transformer doesn't degrade as quickly. But in case of PV plant or BESS plant or even wind plant, do you think the generation capacity is going to increase year on year, or even the PV plant capacity is going to decrease year on year like it is degrading for the battery?
degrading year by year.
Right? So even if it's a PV plant, and even though in PV plant you have done DC to AC ratio of maybe 20%, 30%, or 40%, but every year, even the PV modules are going to degrade. In case of PV, there is soiling, lot of other thing, cleaning needs to be done, and a number of things, right? So because year on year also the transformer capacity may not reduce that much drastically, but the PV generation capacity or the PV maximum power or the battery storage or export maximum power is going to decrease at a slightly higher rate than a product degradation, right? You can even ask your supplier to give you transformer degradation chart. Generally, they will commit you probably same life, right? But even they can give you a degradation chart if you want it before ordering, right? So mainly what happens is in PV plant or even in BESS plant. So one, because the plant itself is going to produce lesser energy year on year, and obviously at a lesser, slightly lesser, I'll not say it's going to reduce like 10, 20, 30%, but maybe 1 or 2% every year on year, right? So that's why. And second, as our friend said, in case of PV, again, the peak generation is happening only for 1 or maximum 1 to 2 hours in a full day, that too probably in summers or somewhere between winters and summers, right? That is somewhere like in Feb, March, April. So that is where the peak generation happens. There might not be generation during cloud, rainy, or overcast condition, or even in winter when the days are short, right? So what does that mean? That this transformer, a normal transformer which is used in plant, it is continuously loaded 24 by 7 and 365 days in a year. Only it is stopped during shutdown. But this transformer, the full night time for PV, the complete night time, it is under no load condition. It is not discharged, but it is operating under no load. And even in daytime, 8 to 9 hours, it's not working at full potential. Only for maybe 1 to 2 hours max, it is going to operate at full transformer rating, and that too maybe or maybe not. I'll say it will not go at full even for 2 hours. It may be less than 1 hour or half an hour only when it will be actually at full, not even for 2 hours. It may be close to that, but not full. Agree to this,
Yes.
right?